Hey guys, we are in our free online coaching classes for the NET examination, and this video will be the lecture 2 on this series. And the topic is the physical properties of seawater, and the book which I referred is the Introduction to Chemistry of Sea by Michael Filson. And this topic is in the fourth heading, that is the ocean and atmosphere, which is in the part B. And this video is exclusively for the physical properties of seawater. We will do a separate video on chemical properties of seawater. So to begin with, the water makes up more than 96% of the seawater. So it is appropriate to begin with a short discussion of properties of water itself. Not only that, the Earth's overall weather and climate is several way controlled by the physical properties of water itself. So we are going to see some of the interesting and important properties of this water. The first one is that it expands when freezing. Most of the liquid, when you freeze, what happens? It will try to contract, right? But the water is among the few liquid which will try to expand while on cooling. And also, the infrared absorption causes the water vapor to be the most important greenhouse gases. Without that, the earth will not be green, right? Not only that, it radiates back most of the incoming solar radiation as it is in the cloud form. So that saves the earth. And variation in its isotopic composition provides insight to several aspects of the earth science. Like you can use the water isotope to identify and calculate the climatic temperature also, right? The chemical property of water, that is perhaps the most important to the marine chemist, is its high solvent power for polar substances and substances that form charged ions in solution. And if you remember the periodic table, you know that the classification of elements is based on the some what do you call the arrangement of physical properties, right? So if you see this series, that is the oxygen, sulfur, selenium, and tellurium. And if the tellurium join with H2, their boiling point will be somewhere near 0 degrees Celsius. And the selenium joins with H2, its boiling point is somewhere near minus 40 degrees Celsius. If sulfur joins with H2, its boiling point is somewhere near minus 50 degrees Celsius. In the series at the top, that is O, when it joins with H2, it should be somewhere near minus 60 degrees Celsius. But actually where it is 100 degrees Celsius. That is, the boiling point of water is 100 degrees Celsius, right? And this is an unusual property, and this point suggests that the water molecule must be exceptionally attracted to each other, and this strong tendency for the molecules having high hang together is also advanced to explain many of the other anomalous properties of water. So this is the very first thing, that is the boiling point is high. Instead of minus 60, it is somewhere near 100 degrees Celsius, and that is due to the molecular structure or the atomic structure of the water itself. That you can see the hydrogen bonds joined together at an angle of 104.5 degree, which is aligned in only one side. And this is a small tendency, and there is a small tendency for the elements electron to be concentrated towards the oxygen and away from the hydrogen atom. So that is weighted average location of negative and positive charges. So it will act as negative and positive, and that is called the dipolar property of water. And this feature enables to dissolve most of the substance that can be converted into bipolar, that is positive and negative, right? That is ionized. So this is the reason, the atomic structure is the main reason for this anomalous property. And there are some other properties and their effects that you can see in this table. The first thing is that the high boiling point, the high melting point, the high specific heat capacity of the water, the high heat conductivity of the water, the high heat of evaporation of the water, and the high heat of melting. So all these properties, or some of the important properties of water and their effects, is that all these properties relating to heat cause water to be important in moderating the temperature extreme. And without that, the difference in the high and low in the earth, that is temperature difference in the high and low in the earth, will be very high, and that will not lead to any life to exist in the world. As the water is there, the moderation between the extreme is controlled, and that leads the earth to be green, right? And the next property is that its maximum density is around 4 degrees Celsius, and this contrast between the ocean and lake that you will see in the forthcoming slides. And the high surface tension, which you can see during the rainfall, you can see droplets, and when the sea water breaks at the wave, there is also formation of water droplets, and this shows that it has high surface tension. And the high viscosity of water is essential for the biological activities to exist. And the high dielectric constant shows that the good solvent of ionizing substances. So if you see, this is an structural arrangement of ice. When ice is formed, what happens? The water molecule become oriented into a regular tetrahedral structure that is shown in the figure, and this occupies more volume than a liquid state. So what happens actually? The water will try to expand, and the expansion is somewhere near 9 percentage, and this you might have read as frost wedging, right? When the water is entered into a crack and when it got freezes, what happens? The water will expand. The expansion is 9 percentage, so that's lead to the expansion of the whole crack, and this is called as frost wedging. And peculiarity of pure water is that it is cooled at density reaches maximum of 3.98 degrees Celsius, that we had seen in a previous slide as approximately 4 degrees Celsius, right? The actual temperature when it get high density is 3.98, and above this freezing point the decrease slightly towards the freezing point. Okay, so what happens when a lake that is for fresh water say is getting cooled, the denser water fills the lake at this temperature, right? So if the lake reaches from towards 4 degrees Celsius, it is somewhat near completely of high dense water, which is somewhere near 3.9, right? The ice is even less denser, which is formed on the water, so the low density ice will float on the surface of the water, and that leads to the lake to remain ice on the surface and the water on the bottom. And this leads to what, the existence of living biotics under the ice cap. So if this property is not there, that is the water high density is not at 3.9 degrees Celsius, what happens? The complete lake may get converted into ice, and all the living things that was earlier there, that will get extinct, right? That will get dead, and after some time, what happens? There is nothing, right? Not only that, the presence of salt in the water must disturb the tendency towards the oriented ordered arrangement. So what happens? The more salt, the lower the temperature. So this thing what you see in a freshwater lake will not exist in an open ocean. So in open ocean, what happens? That consists of salt. So this type of thing will not happen, as the water is not in a pure state though. So the maximum density is not at 3.98 degrees Celsius. So this phenomenon is important in ocean because it leads to the necessity for the entire water column to cool to the freezing point before freezing begins. So this is the total different thing which is happening in the ocean as well as in the freshwater lake, which is good for the freshwater lake as it is in pure state. The living things can exist there even at the top surface what freezed, and in open ocean what happens, the thing will not disturb the other living organisms, right? So this is a curve which shows the density of water with different in temperature, that you can see the saline water's density is moving somewhere like this. Its density increases when the temperature decreases. So you can expect seawater when you move down in a seawater, what happens? The density increases from top to bottom. But in a lake or in a cold lake, you cannot expect the same thing. When the water is at 3.98 degrees Celsius, the lake will be at a high density. When it moves lesser or even more, the density will decrease. So you can see up and then down in a freshwater lake, that is distilled water they have mentioned here. I have grouped my videos according to the category that you can check in my playlist. If you want to connect with us, these are the links for that. You can also support us by like, share up and subscribe. Thanks for watching. Have a great day.